Here we got another volume of Revolution, but we have a scary revolution about the y-axis. Actually, it's not that scary, so let's get to it. It says that we're dealing with the function x squared, or I should say the curve, the graph, whatever. And it's bounded by the y-axis and the horizontal line at y equals 1. Well, not it, the area is bounded by these lines. And so there's your y equals 1 line, and there's your area, mastos. Okay, so it's bounded by the graph. Okay. Now, it does say it's in the first quadrant. That kind of hinted to me. That's why I only drew the first quadrant right here. I need all the other stuff, all the other quadrants. But now, since we are rotating about a vertical axis, okay, that means we need to do integrals with respect to y. So our integral is going to look something like this. We're going to have an area function where we plug y's into it. Don't forget your dy, because that's what we're taking the integral with respect to. And then we're going to have our lower bound and our upper bound also be y's. And so it's all about the y's here, Stews. Okay, so let's start out with the y's, the lower and upper bound. That's pretty simple. We know the bottom one is 0 and the top one is 1 because that equation is 1, y equals 1. So I put those lower and upper boundaries on, and now it's time to define my area, but we have to define it with respect to y, not r. Okay, so what is r? R is the radius. The radius is found from the axis of revolution to the curve. That's going to be your radius. And I'll draw you guys a picture in a second. But before I do that, let's rewrite this curve. Instead of with respect to x, let's write it with respect to y. And so in order to do that, we have to get the x alone. To do that, we have to square root both sides. Then we get a plus and a minus. But we don't care about the minus because, why? Because we are in the first quadrant. And we only want this side. That's all we care about. All right, so we put the square root of y in there, and here's my circle I wanted to show you guys really quick. If we were to rotate this guy around this x to the second power, if we were to rotate that around the y-axis, our cross sections would look like this. So I drew one cross section, and the thing is this: is we want to be able to pick a y and plug it in, and then that would give us the x. The x would be the radius. Right? So we take the y, we plug it in, we get the x. And so that's why we have to do our integral with respect to y. Okay, so now let's take our integral and plug our new fancy schmancy formula inside of it. I did put the pi on the outside of the integral, and I actually simplified this at the same time too. Why? Because if we take the square root of y and we square it, the squared and the square root cancel each other out. Yay! All right, so now let's do the antiderivative. The antiderivative of y is going to be y to the second power. Then we have to divide by 2, or you can multiply by 1/2. I plug in the 1 and the 0, and it looks like I'm only left with pi over 2. Well, that was a quick one.